All right, so here's the special thing about all these theorems from this point out. We've been, what were you asking me, Jerome? Today? Yeah. All right, so we talked about dividing polynomials, and we had to do long division, and we said you can use long division anytime, it doesn't matter. But we divide by a special, there's a special type of binomial that we divide by a lot with polynomials, okay? And y'all will probably remember this when you see it from Algebra 2. We divide a lot by x plus some number k or x minus some number k. Now, a couple things to look at when you see this. Notice that the x does not have a coefficient. Or an exponent. So what the remainder theorem says is, if you divide any polynomial, okay, any polynomial in the whole wide world, it doesn't matter what it is. So we'll say f of x is any polynomial. And our general form is x minus k. So when we start talking about k, we change the sign of it, okay? So if we divide, come on, f of x by x minus k, then the remainder and I'm putting this in words that I think if you go back and read it, you'll understand, so it's not real mathy. If you divide f of x by x minus k, then the remainder is what you get. Come on. If you plug in k for x. Okay, and I'll show you an example of exactly what I'm talking about. Let me show you, this can be a bit convoluted when you see it in words, but let me show you mathematically what this looks like. You're not done? I'm sorry. All right, let's say, this is an example. Let's say f of x is 3x squared plus 7x minus 20. Let's say I divided by x minus 2. What's the remainder? So without actually putting it in long division and dividing out and going through, I can find the remainder since it's just x minus a number. Okay, there's no coefficients. Well, but you got to change the sign of k when you put it in. So be positive 2 that you're plugging in. So what you want to do to find the remainder is you do f of 2. Okay, which means 3 times, so make a note, you probably want to make a note somewhere. Change the sign. That's this. That's the 2 you use. It's f of k. Yeah, that's the k. So 3 times 2 squared plus 7 times 2 minus 20.
That is the k input?
Do what? The k replaces the x's to find the remainder. All right, so do your exponents first because they come first in order of operations. So 2 squared is 4, and 4 times 3 is, so you got 12 plus 14 minus 20, which would be what? 6? No. Yes. So if you were to divide this all the way out, you would find that the remainder is 6. 16 minus 26 minus 20.
So, 11, 6, 7, 8. But where's the problem?
The answer is 6. I just asked you, I didn't ask you for what you get when you divide. I just said what's the remainder if you divide. Always change the sign. The K sign. So you might want to put over here, let's go back to where we wrote it out on the notes here. If we divide x of...
So if it's plus, that would be minus, and if it's minus, it's plus?
Yes. So to generalize this, f of k is the remainder. Change the sign. Oh my goodness. Let's say we take the same f of x. Obviously this one's going to be a little bit different. There's going to be something different about it. But it's going to help me introduce the next topic. Minus 20. Let's say you divide it by x plus 4. I don't want to know what you get when you divide right now. I just want to know what's the remainder. What am I plugging in? What'd you plug in? Negative 4.
So what do we do with this?
Don't look up if you're still doing it. I'm going to just... I got 0 too.
So what do we do with this?
So you take this and you change the sign of it and you plug it in. Huh?
We always have to do that?
Yes.
We always have to change the sign.
Yes.
So we'll leave it at 4 is right there.
Even if it's yes. Yes, always. What if what?
Before.
You just change the sign and plug it in for x.
I know,
Yeah.
we just stated it.
Mm-hmm. Yes. Huh? I'm fixing it. I'm going to get to that. I'm going to show you. All right, so the question is, what do we use the remainder for? So I want you to think about something for a minute. If you divide by something and you get no remainder, what does that tell you? Okay, so give me another mathematical word for what you divided by, what you get. If I said 6 divided by 3 equals 2, and there's no remainder, what relationship do 3 and 2 have to 6? They're multiples. Give me another word for that. Factors. They're factors, right? If you divide by something and you get 0 remainder, then that means you have found a factor. If you divide 0 remainder, and factors multiply together to give you what you started with, right? In other words, I could take 3 times 2, which are factors of 6, multiply them together to get back to 6. Okay? So let's think about just a second what this means. If I have this f of x, I divide it by x plus 4, I get no remainder. That means x plus 4 is a what? Starts with an F, we just said. A factor of the polynomial. We have been factoring a lot of polynomials, okay? how might I find the other polynomial, the other factor that makes up this polynomial? Y'all can do this. If I knew that 3 was a factor of 6, how do I find the 2? Divide. Okay? When you have one factor, you divide to find the other factor. So let's write that down. If you have one factor, divide to find the other factor. So, what I can conclude from this is if f of k equals 0. So if I plug it in and I get 0 when I plug it in, right? That means I divided by x minus k and there was no remainder. Then that tells me if f of k equals 0, then x minus k must be a factor. So here's what I want you to do. I want you to look at this f of x, and I want you to find the other factor.
Which one? The one with the real one?
I've already given you one, because when we plugged it in, we got 0. So I want you to find the second factor here. So we know f of x equals 3x squared plus 7x minus 20. We know that x plus 4 is a factor. What's the other factor?
X.
How do you find the other factor? We just said it. Divide. You have one factor and you need the other factor, then you divide. So divide it. Long division. This is long division. And then I'm going to show you synthetic so I can show you how it parallels.
Please show me.
Do it long division on this one and then we'll do.
So we do long division already?
Yeah.
16 yard.
This is a quick one because it's just a quadratic divided by a linear function. What do you multiply x by to get 3x squared?
3x.
Mm-hmm. 3x squared plus 12x. It's 3x what? Minus 5.
No. Yeah.
Notice when we divided, we got no remainder, as I should, right? If you divide by a factor, the definition of factor is it goes in evenly, right? No remainder. So what this tells me is that x plus 4 times 3x minus 5 is the factored form of this. Now you have factored before and you have factored quadratics, and you could factor this one multiplying a times c together and splitting up the middle. This is another way to do that, okay? But you don't know how to factor big long polynomials, which is why we do long division, or we do division to find factors and dividing, okay? Does this make sense to you? You should have done this last year in Algebra 2.
Yeah.
Okay?
Big facts.
All right, if I'm going too fast, tell me, because I'm kind of assuming I'm just brushing you up on what you already know. All right. Let me show you synthetic so it'll help you be quicker. This only works when you're in the scenario of x minus k. Okay? So you cannot, if there are exponents or coefficients on that x, you cannot use synthetic. But if you're dividing by something that looks like this, you can use synthetic. I'm going to use that same example we keep using so that you see what happens, and then I'll do a little bit harder one. But I really want you to see that long division and synthetic do the same. So our same f of x, we've divided this thing every which way. Divided by x plus 4, right? Now, it's okay to get a remainder on these. The remainder deal only tells you, yes, it is a factor, or no, it is not. So we'll do synthetic for the two examples we did. One of them we got a remainder, and one of them we didn't. All right, so here's what you do. On the outside, you're going to change the sign of k and put it outside of an upside down division sign. Then, and you need room for 2 rows inside this upside down division sign. So on the first row, what I'm going to do is I'm going to list the coefficients of f of x, but make sure, if you need them, that you include placeholders. If you don't, this really messes up. That's what you do, yeah. All right. Do y'all remember synthetic? Drop the first term. That's right. Multiply and add. Multiply and add. Now remember when we did long division, we got 3x minus 5, right? And look down at the bottom at what we have. This is always, you always label them from right to left, so opposite. This is the remainder, the constant, x. If I had another column, it would be x squared, and it would continue counting up, okay? Yes, it does. All right, so this tells me that when I divide these two things, I get 3x minus 5. A lot quicker and easier than long division, right? My remainder theorem holds true. Whenever I plugged in -4, I got 0. Okay. Let me show you the other example, then I'll do one a little bit longer, and we'll probably stop there for today and finish up on Monday. Let's do, I want to do one harder, but I want it to have a remainder. Let's do f of x. Let's divide this by x plus 3. Is it too easy?
Tell him, Jackson. I can do this in my head right now.
Well, why don't you come up here and do it for us? That'd be lovely. Make sure you interpret your answer now. I'm going to step over here so you don't breathe too close to me, just in case.
Y'all got it written down? So do a synthetic, right?
Synthetic, yeah. Definitely, if you ever can do synthetic, you want to do synthetic because it's so much quicker and easier. It might be easier to write on my tablet. Well, you can do whichever.
Oh, okay, use one of these.
Yeah. If it's x plus a number or x minus a number, you can use synthetic. As long as there's no coefficients and no exponents in your thing.
Oh, so that has.
Make sure you check, Jackson's doing this absolutely right. Keep going, Jackson. But make sure you check for placeholders every single time.
Oh, no, hold up. How do I erase that?
Just hit undo.
All right, listen, isn't it?
Hit undo on that toolbar down the bottom, that little circle thing.
Would that be -3 minus -3?
Undo?
Or just -3 minus
All the way on the
3?
bottom, it's like a arrow.
-3 plus -6. You add the column.
Your thing's tripping.
I know, that's why I always.
You know how to do it, you know how to do it, Jackson.
Yeah, what are you
See, y'all
talking about?
Ask why. Yeah, keep going.
Oh,
22.
20, there you go.
Yeah.
My X's were up.
This one you'd have a remainder on.
That is correct.
You would. Wow. Good job, buddy.
What's the remainder?
Wait.
There you go. Now you see why I hit it all the time? All right, so that's a negative. Interpret your answer.
You know how to do it, boy?
Yeah, I got it.
No, you got, I would, oh, yeah.
All right,
Are you sure?
No,
That's
he's
-6.
not sure. No, he's.
and then measure 9. Yeah. That's plus 22.
Oh, is it?
Let's see if he gets it. Ah, you got it! Good job, Jackson. Good job.
That's how we do it.
All right. So, thank y'all.
Just let us stay here.
And let's see if you really understand. Let's say, let me change this up first. Let me change this to, now you do this quickly on your paper, and I know you won't have any trouble doing this really quick. F of x equals, let's take the same f of x, and you'll see why I changed this. And let's divide, instead of dividing by x plus 3, let's divide by x minus 3. Divide it out on your paper and tell me what's happened. Yes, definitely synthetic if you can. Tell me why I might have picked that to divide by. That's exactly right. If it's x plus a number or x minus a number. X doesn't have any coefficients or exponents. It's just plain old x plus something or plain old x minus something. All right. So I want you to look at this just a second. I want you to think about something. We know when we divide this, we get 2x squared plus 3x plus 4, right?
Yeah.
What can you multiply that by to get back to 2x cubed minus 3x squared minus 5x minus 12? So do we all agree that this is the same thing as this?
Yeah.
Think about zeros and how we find zeros. How do we find the zeros of a function? Think back to quadratics. We factor and we set each piece to 0, right? Tell me, just looking at this, what one of the zeros of this function is. 3. Why 3? If x minus 3 equals 0, because this is in factored form, right? This is fully factored. Then x equals 3 is a 0, okay? This comes back to another theorem, done that in here, okay? We said that if f of k equals 0, remember I said if f of k equals 0, then x minus k is a factor. Well, what it also tells us is that x equals k is a 0. And that's very, very, very important. Okay? So if you can divide and you get no remainder, it gives you two things. It gives you a factor and it gives you a 0. Okay? The number that you plug in whenever you got 0 is a 0. It's where it crosses the x-axis. All right. Yep, let me just look back at these ones we just did and just show you how this, all right, that one didn't, that one had a remainder. So we're really looking for ones that have no remainder because those are what tells us the most. Here we go. Because this had no remainder, that tells me two things. That tells me that x plus 4 is a factor. And that also tells me what's one of the zeros. What's k?
4
No, it's k. You got to change the sign. Negative 4 is a 0. Okay? It's just an extension on what you already knew, what you've already been doing. We're just doing it on a little bit bigger scale now. All right, let me tell you what I want.